Hari Om. Welcome. So let us continue solving the NCERT questions. We had completed the first 8 questions, so let's proceed to the next one. In the next question it is given that we have two charges Q1 and Q2 or QA and QB which are placed at 0, 0, minus 15 and 0, 0, plus 15. This coordinate is why I have placed them in the z-axis. Now the value of Q1 is 2.5 into 10 to the power minus 7 and Q2 is minus of the same. So we have to find net charge. So total charge is equal to Q1 plus Q2. As you can see, both are same and of opposite sign. If you add them, they will cancel. So total charge will become 0. Next, we have to find dipole moment. Dipole moment is given by P is equal to charge into distance between them. So any one charge and the product of any one charge and distance between the two charges. So take any one charge 2.5 into 10 to the power minus 7, and the distance between them is, if this much is 15 centimeter, this is also 15, so total distance is 30 centimeter or 0.3 meter. So this becomes 0.75 into 10 to the power minus 7. This is coulomb, so coulomb meter. Or the dipole moment, the magnitude of dipole moment is 7.5 into 10 to the power minus 8 coulomb meter. But since dipole moment is a vector quantity, we also have to denote its direction. What is its direction? The direction of a dipole moment is from negative charge. As you can see, Q2 is negative charge. So the direction of P vector is from minus to plus. Always the direction of dipole moment is from negative to positive. So as you can see, the direction is B to A or along negative z-axis. Alright, so let's proceed to the next one. So in the next question, that is the 10th one, it is given that we have a dipole moment, we have a dipole of dipole moment 4 into 10 to the power minus 9 coulomb meter. So let it be something like this, and it is placed in an electric field. So there is a uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb, and the angle between dipole moment and electric field is 30 degree. So this is very straightforward question. We have to calculate the torque on this dipole. As you know, torque is equal to P cross E. So tau is equal to PE sin theta. So you know the value of P. So 4 into 10 to the power minus 9 coulomb meter. E is 5 into 10 to the power 4 coulomb meter into E is 5 into 10 to the power 4 Newton per coulomb into sine of theta. Theta is 30 degree. So this becomes 5 into 4 is 20 into 10 to the power minus 5. Sine 30 is 1 by 2. So this becomes 10 into 10 to the power minus 5 Newton meter. So 10 to the power minus 4 Newton. So this is the torque which is acting on the dipole. And the direction of this torque will be, how to get the direction? So tau is given by P cross E. So point your fingers in the direction of P, curl it to cross to E. So if we curl the fingers from P to E, the thumb points in the direction of torque. So torque is acting inside the board or inwards. Torque is acting inwards. Alright. So let us come to the next question. In the next question it is given that a piece of polythene is rubbed with a wool, and polythene gets a charge of minus 3 into 10 to the power minus 7 coulomb. You should give importance to the negative sign which is present here. So on rubbing a polythene and a wool, polythene gets minus 3 into 10 to the power minus 7 coulomb charge. So it has asked what are the number of electrons that have transferred. So what to do? We have to use the formula Q is equal to Ne. This formula comes from the quantization of charge. Alright, now since polythene has got negative charge, that means it has accepted electrons, or we can say that the electron transfer is from wool to polythene. So this is the direction of electron transfer. That is why polythene has got negative charge. You must have studied in chemistry also. Elements like chlorine, they accept electron, and that's why it has a charge of Cl minus. So polythene on accepting electron became negatively charged. So how much charge? Let's apply this formula. So Q is this minus 3 into 10 to the power minus 7 coulomb. N, we have to find N is the number of electrons, and E is the charge of a single electron, that is minus 1.6 into 10 to the power minus 19 coulomb. So minus and minus will cancel. So N will be 3 into 10 to the power minus 7 by 1.6 into 10 to the power minus 19. So after solving this, you will get something around 1.875 into 10 to the power 12. So this much number of electrons have transferred from wool to polythene. Now, the next part of this question is how much mass has transferred. As you know that mass of one electron is 9.1 into 10 to the power minus 31 kg, and the number of electrons that have transferred was 1.875 into 10 to the power 12. So total mass is equal to this into this. This is the mass of one electron and this is the number of electrons. So total mass is 9.1 into 10 to the power minus 31 into 1.875 into 10 to the power 12 kg. So the total mass is 17.0625 into 10 to the power minus 19 kg. And if we want to write it in scientific notation, this will become this much. This is the total mass that has been transferred. Alright. So let's come to the next question now. In this question, it has been asked that it has been given that we have two insulated copper spheres and both of them are charged equally, that is 6.5 into 10 to the power minus 7 coulomb. They are separated by a distance of 50 centimeters. So what will be the force? So very easy, applying Coulomb's law, F is K Q1 Q2 by R square. The value of K in air is 9 into 10 to the power 9. Q1 is 6.5 into 10 to the power minus 7. Q2 is also same. And distance between them is 50 centimeters. So that's 0.5 meter into 0.5 because we have a square. Now solving this, we will get 1.521 into 10 to the power minus 2 newtons. This is the force that will be acting. This is the electrostatic force of repulsion between these two charges. Now it has asked that if we double the charges, so whatever charge was here, double the amount, whatever charge was in B, double the amount, and decrease the distance by half, what will be the value of this force? So instead of calculating again, let's follow something else. So as we know, force is K Q1 Q2 by R square. Let this be the new force, that is after changing. So F dash is equal to K. Now Q1 is twice times the initial charge. Similarly Q2 is also twice. R is half. Now the distance is half of the initial one. So the new force is equal to K 4. So 2 into 2 4 K Q1 Q2 by, this will be R square by 4, so which we can multiply. So F dash is 16 K Q1 Q2 by R square. And as you can see, we have already calculated K Q1 Q2 by R square once, and that is this much. So the new force will be 16 into whatever we have got here. So indirectly the electrostatic force of repulsion will increase. So this value will come to be something around 24.336 into 10 to the power minus 2 Newton, or 2.43, rounding up 4 into 10 to the power minus 1 Newton. So this is the new force between both of them. Alright. Okay, so let us proceed to the next question. In this question, it has asked that we have two same charges that we had in the previous question. Now a third uncharged sphere is first brought in contact with A, then it is brought in contact with B. So what happens there? Let us consider we have a charge Q here and charge Q, because both of them are same. I am not denoting it by 6.5 because that will be a bit difficult. So here let us denote 6.5 into 10 to the power minus 7 coulomb by Q. Now the charge which is present here is 0. So the basic concept here is, if we have two similar objects of different charges, then after they are touched, the net charge on each object is their average. So suppose this is 10 coulombs, this is 4 coulomb before touching, and if we bring both of them in contact after that, so what will happen? Basically this has higher charge, this has less charge. Some amount of charge will flow from the first one to second one. Up to how much will it flow? Unless and until an equilibrium is reached. So when will the equilibrium will reach? When both of them will be, so what is the average of them? 10 plus 4, 14 by 2. So when both of them will get charged to 7 coulomb, an equilibrium will reach. So basically we have to calculate the average. Alright. Now, so we have three different charges here, A, B and the uncharged one. Let it be C. So this has a charge of Q, this also has a charge of Q. When here there is no charge, so when C and A will come in contact, the average of them is Q plus 0 by 2, which is equal to Q by 2. So the charge in A will become Q by 2 and the charge in C will also become Q by 2. Alright, initially the charge in A was Q, here it was 0, half of them will come to here. We are just calculating the average. This is the method of charging by contact. Now we will bring C and B in contact with each other. Now as you can see, the charged object C already has some charge. So now the average of them will be Q plus Q by 2 by 2. So this is Q plus Q whole by 4. So 3Q by 4. That means B will become 3Q by 4. C will also become 3Q by 4. Now this charge C is taken away and we have to find the force between these two charges. So distance is 50 centimeter as it was given earlier. Now force is K Q1 Q2 by R square. So K into Q1 is Q by 2, Q2 is 3Q by 4 divided by R square. So 0.5 into 0.5 newtons. So this is 9 into 10 to the power 9. Q is this much. So 6.5 into 10 to the power minus 7 into 3 into 6.5 into 10 to the power minus 7. I am just putting the value of Q whole divided by 0.5 into 0.5 into 2 into 4 is 8 and newtons. So we are going to get 570.375 into 10 to the power minus 5 Newton, or 5.7037 into 10 to the power minus 3 Newton. This is the answer of question number 13. Alright. Okay, let's come to the next question. In this it is given that we have two different seeds. One has positively charged and the other one is negatively charged. Three particles. The trajectory of three particles are given. We have to predict the sign of them. As you can easily guess, since the first particle is getting attracted towards the positive seed, that means it must be a negatively charged particle. Similarly, second one is also getting attracted towards the positive seed, so it should also be a negatively charged particle. Whereas third one is getting repelled from the positive seed, or it is getting attracted towards the negative one, so this is a positively charged particle. Alright. Now, as you know that we have a formula F equals to QE. So higher is the charge, we have more amount of force. So more amount of force will act on the particle which is higher charge. Suppose you have an electric field and you place two different charges. One is 5 coulombs and another is 10 coulomb. The charge 10 coulomb will face more force. So the object which has higher charge, or the object which has higher charge to mass ratio, it will deviate more, or it will experience a force more. So out of these three, which has deviated more? You can easily see that the third particle has deviated more. So the third one has highest charge to mass ratio. Alright, coming to the next question. It is given that we have an electric field of 3 into 10 to the power 3 Newton per coulomb and its direction is I cap. I cap means x-axis, so positive x-axis. Electric field is uniform. Now, as you can see, 3 is a constant, 10 to the power 3 is also a constant. So this represents an uniform electric field. Hence I have drawn parallel lines. Suppose it would have been 3 into 10 to the power 3x Newton per coulomb. This is no more a uniform electric field. You might get questions like this. Alright. So now we are asked to find the flux on a sheet of paper which is parallel to YZ plane. Means it is kept something like this, which is in the form of a square of 10 centimeter. As you know, phi is E dot A, electric field vector dot area vector. So E A cos theta, where theta is the angle between electric field and area vector. If this is the area, so area vector will be towards x-axis. So if you have a sheet like this, area vector is perpendicular to that area. So the direction of E vector and A vector is same. So we can say that theta is 0. If theta is 0, cos 0 is 1. So this is phi equals to E into A. E is 3 into 10 to the power 3 Newton per coulomb, and area is, since it's 10 centimeter, so 0.1 into 0.1 meter square. So this becomes 330 Newton meter square per coulomb. This is the expression for flux. In the next part of the same question, it is given that if angle is 60 degree, then what will be the flux? As easy as it comes, so phi is equal to E vector dot A vector. So EA cos theta. E is 3 into 10 to the power minus 3. Area is, 3 into 10 to the power 3. Area is 0.1 into 0.1, because we have a square of side 10 centimeter and theta is 60 degree, so cos 60. So 3 into 10, this will become, cos 60 is half, so 15 newtons meter square per is the flux, which will be acting if we have the area vector making an angle 60 degree with x-axis. Alright. In the next question, it is given that if we take the same electric field as in the previous case, that is 3 into 10 to the power 3 I cap Newton per Coulomb, then what will be the net flux through the cube, which is placed in such a way that its faces are parallel to the axis planes. So what to do in this case? It's very easy question. Net electric flux is number of field lines leaving the surface minus number of field lines entering. As you can see, the number of field lines leaving the surface and number of field lines entering the surface are same. Why? Because we have a uniform electric field. So the net flux is 0 in this case. Suppose if we did not have a uniform electric field, suppose our electric field would have something be like this. In this case, the number of field lines entering and number of field lines leaving is not same. So there will be some net flux. Hence, in this case, the net flux is 0. Alright. So let's stop here today. In the next video, we will cover the next few questions of NCERT from this same lesson. Thank you.